I'm presenting RPGPref, a planning heuristic that uses playstyle preferences to model player action and choice. The important thing to take away from that title is preferences to model player action and choice. Effectively, what we want to do with this system is be able to generate plans that can express how a player wants to play through a game level. And in order to do this, we use both proposition and action preferences. So let me talk really quick about action preferences. Some of you might not know why I'm even talking about this, but basically you might have the question of why don't we express preference as goal choice instead? Plenty of planners do this, particularly narrative planners can express character traits through what goals they choose to approach. In our case, we're really looking at situations where, say, a designer has designed a level where there are multiple paths in order to reach the end of the level, and we're trying to figure out, how certain types of players will approach those paths in order to reach the end of the level. You might also know that preference-based planners already exist. It is kind of an entire field. PDDL has an extension for preferences. But what if the player really cares about how they are completing the steps in order to reach the goal, rather than just what changes in the world state? The preferences in PDDL are proposition preferences, not action preferences. In the worst case, if you have a game level and there are two actions a player can choose that have the exact same effect on the world state, it's going to look the same to the majority of planners, but maybe the player strongly prefers the actual gameplay or the things that they're doing in order to do one of those actions. And so we want to be able to capture that. Really quick, some of you are already going to know this, but heuristic search planners and relaxed plan graphs, because I'm going to be talking about them. Heuristic search planners use a heuristic to evaluate which step to add to a solution planner next. It's just going to build a solution plan for a problem. The heuristic guides them there. A relaxed plan graph is a method that you might use in a heuristic in order to kind of look forward to predict what steps would be taken in order to reach the goal. The heuristic search planner can then use the number of actions that are in that relaxed plan in order to estimate the distance to the goal. So let me talk really quick about RPGPref then. Basically, we assume that the agent has a set of preference values. In this case, they're values from -1 to 1, most avoid to most prefer, for all actions and propositions that are relevant to them within the domain. This doesn't have to be a complete set. Anything that isn't in the set it has a value of 0, which is neutral. We carry forward preference values from layer to layer when we're building the relaxed plan graph. And then basically every node in the relaxed plan graph ends up with a value associated with it that kind of tells you the things that led up to that part of the relaxed plan graph. And then when we get to relaxed plan extraction, it's mostly standard. All we're doing is we're using those values in order to guide the relaxed plan extraction process so that we end with a relaxed plan that has things that have led to high playstyle values. And ultimately, the idea is that upon completion, you provide an action set, which was your relaxed plan, which obviously includes the count of actions in the relaxed plan. And this is designed to work with a standard heuristic search planner. So standard heuristic search planner will look at that count of actions, and when it's evaluating each step, we'll choose the one that has the lowest count. But we also require the heuristic search planner to have action pruning, because what that does is it constrains the set of actions that the planner looks at for each step to only the actions that were in the relaxed plan. And this is entirely essential because the actions in the relaxed plan are the things that lead you to those high playstyle values. So if you don't consider those first, then it's just going to work as shortest path. Ultimately, this produces solution plans which avoid unnecessary actions and attempt to maximize playstyle value. All actions that are in the relaxed plan are there for a reason, but they are simply biased towards high playstyle actions. Anyway, I know that this wasn't a super long time for me to give a presentation, but for more information, you can find me at the poster session. You can also read the paper. There are, full algorithms there and everything else. Thank you very much.